So hello everyone, my name is Anmol Saini and I am your chemistry SME, and today we are solving BPT 18 questions. Okay, so let's start. So question number first, suppose the element X and Y combine to form two compounds. Okay, first one is XY2 and second is X3Y2. Okay, when 0.1 mole of XY2 weighs 10 gram, okay, and 0.05 mole of X3Y2 weighs 9 gram, okay, and we have to calculate the atomic weight of X and Y. Okay, so first of all, we know that number of moles is equals to weight divided by molecular weight. And now we are given with two equation. Okay, for first compound XY2, number of moles is equals to 0.1 and weight is 10 gram, and we know that the molecular weight will be X plus 2Y, because we have one component of X and we have two component of Y. Okay, so we will get X plus 2Y. Just solving this equation, X plus 2Y is equals to 10 divided by 0.1. So 10 divided by 0.1 equals to X plus 2Y is equals to 100. Okay, so this is our equation number first. Now for compound number 2, which is X3Y2, number of moles is 0.05 and its weight is 9, and molecular weight we don't know, so its molecular weight will be equals to 3x plus 2y, 3x plus 2y. Okay, 3x plus 2y. Now just solving this equation, 3x plus 2y is equals to 9 divided by 0.05, which is equals to 180. Okay, so it will become 3x plus 2y is equals to 180. So now we have two equation. First is x plus 2y is equals to 100 and second is 3x plus 2y is equals to 80. So now solving these two equation. Okay, x plus 2y is equals to 100 and 3x plus 2y is equals to 180. Now subtracting equation number 2 from 1, we'll get 2y will be cancelled out and minus 2x is equals to minus 80. Okay, so x will be equals to 40. S we will get 40 and we have to calculate y now. So value of x I am putting in this equation, 40 plus 2y is equals to 100. So 2y is equals to 60 and y is equals to 30. Okay, so what we have to calculate, the atomic weight of x and y will be 40 and 30 respectively. So option number A is our correct answer. So question number 52. If the Avogadro number Na is changed from 6.022 into 10 raised to power 23 mole to 6.022 into 10 to the power 20 moles, this would change. Okay, so there are four options. First, the mass of 1 mole of carbon. Okay, so we know the mass of 1 mole of carbon is 12 gram. We know the mass of 1 mole of carbon is 12 gram. 1 mole carbon, 12 gram. But if the Na value is changed, then the mass of 1 mole of carbon when Na value is 6.022 into 10 raised to power of 20, then it will be equals to 12 gram, which is the actual weight, into the number of Na molecules, 6.022 into 10 raised to power of 20, and divided by the actual Na value. So actual Na value will be 6.022 into 10 raised to power of 23. Okay, so this will be cancelled out and 10 raised to power of minus 3 will be left here. Okay, so there is change in the value, so there is change in the mass of carbon. Okay, so our option A is correct because the mass of 1 mole of carbon is changed here. Okay, so the second option, the ratio of chemical species to each other in a balanced reaction. So here it is talking about ratio. It is talking about ratio. So if there are any molecules in numerator and any molecules in denominator, they both will be cancelled out. So if there is change in any, then there will be no change in the ratio of chemical species to each other in a balanced reaction. Similarly, there will be no change in the ratio of element to each other in a compound. Okay, so the correct answer is option 1. Okay, question number 53, which has the maximum molecule. Okay, So we can calculate the maximum molecule by calculating the number of moles first. Okay. So the mass of nitrogen will be 28. Mass of N2 will be 28. Okay. So mass of hydrogen will be 2. So mass of NO2 will be mass of nitrogen, you can 14, then 32. So it will be 4, 6 and 46. Okay. So here mass will be 46 gram, and for oxygen we know 32 gram. Okay. So if we calculate the mole of each, the highest mole will be for hydrogen, which is 1 mole. Okay. Which is 1 mole. So the maximum number of molecules will be in the option number 2, 2 gram, and the number of molecules will be 6.022 into 10 raised to the power of 23 molecules, which is the number of uh, Avogadro number of molecules. Okay. Now question number 54. The emission spectra of atom in the gaseous phase do not show a continuous spread of wavelength from red to violet. Rather, they might emit only a specific wavelength with dark spaces between them. Such spectra is called. Okay. So here it is saying that for some distinct value there will be bright light, and then there will be dark light, then there will be a bright light of different color, then there will be a dark light. Okay. So what type of this type of spectra is known as? Okay. So this type of spectra is known as line spectra, and this type of spectra is also known as atomic spectra. Okay. So both A and B options are correct. Okay. So both A and B options are correct. Okay. The emission spectra of atom in gaseous phase do not show a continuous spread of wavelength from red to violet. They rather emit only at a specific wavelength with dark spaces between them. This spectra is called line spectra or atomic spectra. Okay. Now question number 55. The ratio of shortest wavelength of two spectral series of hydrogen spectra is found to be about 9. The spectral series are. Okay. So we have to calculate the wavelength. Okay. So the formula for wavelength we can use 1 by lambda is equals to which RH Rydberg constant, then 1 by n1 square minus 1 by n2 square. But here we want to calculate the shortest wavelength. Okay. So this formula can be written as 1 by lambda RH divided by 1 by n1 square. Okay. So now we have to calculate for Lyman series. For Lyman series, n1 value will be 1. So 1 by lambda is equals to RH divided by 1. Okay. So lambda is equals to, here lambda is equals to 1 by RH. Okay. Lambda is equals to 1 by RH. Then for Paschen series, n1 will be equals to 3. So 1 by lambda is equals to RH divided by 1 by 9, because 3 square equals to 9. So lambda is equals to 9 upon RH. Okay. And we have to calculate its ratio. So the ratio will be 9 upon RH divided by 1 upon RH. 1 upon RH. So RH will be cancelled out from RH, and the 9 will be left. Okay. So the correct answer will be option number A, Lyman and Paschen series. Similarly, we can find the ratio for the other series as well, but the correct answer is option number A, which is Lyman and Paschen series. Now question number 56. Which of the following statement is false? So we have to tell the incorrect statement. Incorrect statement. Unit of atmospheric pressure and osmotic pressure are same. Yes, they have the same unit, which can be atm, uh, or you can say Pascal. Atm or Pascal, they both have same unit. And second option is in reverse osmosis, the solvent molecule move through a semi-permeable membrane from a region of higher concentration of solute to a lower concentration of solute. No, this statement is incorrect. They move from a region of lower concentration, from lower concentration to the region of higher concentration. So this statement is incorrect because they move from the lower concentration to higher concentration. The value of molar depression constant depends on the nature of solvent. No, they don't depend on the nature of solvent. Yes, yes, they depends on the nature of solvent. They depend on the nature of solvent. So this statement is correct, It is not the answer because here it is asking for incorrect statement. The value of molar depression constant depends on the nature of solvent. This statement is absolutely correct. Okay. Now D option, relative lowering of vapor pressure is a dimensionless quantity. Yes, because in relative lowering, in numerator we also take the partial pressure, and denominator we also take the partial pressure. Partial pressure. So they both will be cancelled out. So it will be a dimensionless quantity. Dimensionless quantity. Okay, so the correct option will be option number B. Now, question number 57. Here, which of the following binary mixture will have the same composition in liquid and vapor phase? Okay, first is benzene and toluene, second is water and nitric acid, third is water and ethanol, fourth is N-hexane and N-heptane. Okay, so mixture having same composition in liquid and vapor phase are known as azeotrops, and azeotrops boils at the same temperature. Okay, so water and nitric acid as well as water and ethanol mixture are non-ideal solution. So when they are non-ideal solution, then they are azeotrops. Okay, and we know that azeotrops have the same composition in liquid and vapor phase. Okay, so water and nitric acid and water and ethanol, they both are azeotrops. They both are azeotrops. Okay, so both are azeotrops. Okay, so they will have the same composition in liquid and vapor phase. So the correct answer will be B and C. So option number 3 will be correct. And benzene, toluene, and N-hexane and heptane, they are ideal solution. Okay, so they are ideal solution. That's mean they are not the azeotrops, so they can't have the same composition in liquid and vapor phase. Okay. Now question number 58. Metallic bonding involves a sea of delocalized electron shared by metal cations in a lattice structure. What property of metal is directly related to metallic bonding? Okay. So here, metallic bonding result in a sea of delocalized electron that strongly attracts the metal cation. Okay, this strong attraction requires a significant amount of energy to overcome, leading to a higher melting and boiling point for metal. Okay, so the correct answer will be option number A, because the strong bonding, strong bonding will be directly proportional to the higher melting and boiling point. Higher melting and boiling point, because if there is strong bonding between the compound, then it will be high, so it will be, we have to use a very large energy to break its bond. Okay, so it will definitely have the high melting and high boiling point. Okay, so the correct answer is option number A. Now question number 59. Which of the following molecule exhibit resonance structure? Okay, so which of the following have resonance structure? Okay, first CH4. So we can draw the structure of CH4. So here we can't find any resonance. Okay, so the option 1 is incorrect. Now carbon dioxide. For carbon dioxide, one carbon here covered by two oxygen atom. So here there is no resonance as well. So option 2 is also incorrect. Now option number C. So here is the diagram of benzene, and we know that there is a resonance structure in benzene. So there is delocalization of electron. There is delocalization of electron, and benzene show the resonance, exhibit resonance, so it will have the resonance structure. Okay, so the option number 3 is correct answer. We can also check for ammonia. Ammonia has diagram this, H and this, and there is one lone pair as well, one lone pair. But benzene has delocalized, so benzene will have exhibit resonance, so it will show the resonance structures. Okay, now question number 60. Corrosion is the deterioration of a metal due to its reaction with the environment. Which of the following factor can accelerate the corrosion of iron? Okay. First is painting the iron surface. Second, the presence of an acidic environment. Third, contact with a more noble metal, example copper. Or fourth option is all of these. Okay. So the first option, painting the iron surface. While painting can offer some protection for a very few period, for a very few time period, but for future it will create excessive corrosion or damage can create where moisture and electrolyte can accumulate and accelerate corrosion. Okay, so painting will accelerate the corrosion. Okay, now second, the presence of an acidic environment. The presence of an acidic environment will have the lower pH, so it weaks the passive layer of oxide on iron, making it more susceptible to attack. So more compounds can attack there and the corrosion rate will be higher. So it will also accelerate corrosion. Now option number C, contact with a more noble atom. Okay, contact with a more noble atom, example copper. When iron come in contact with a more noble metal like copper, it acts as an anode which loses electron in a galvanic cell and also accelerates the corrosion. Or you can say the rate of corrosion will be accelerated. So the both so all the options are correct. So option number 4 is correct. Here we have to tell which of the following option will accelerate the rate of corrosion in iron. Okay, so all the three options are accelerating the rate of corrosion. So option number 4 is correct answer. Now question number 61. Question number 61. Here we have Faraday constant F relates with the amount of charge passed through an electrolytic cell to the amount of substance produced. Which of the following equation represent the Faraday constant? Okay, so we have the Faraday constant F, we have the amount of charge which is Q, and the amount of substance N. Okay, so we have to find relation between them. Okay, so here the relation will be Q is equals to NF. This is a very basic NCRT formula. Okay. Here Q represent the amount of charge in coulomb, N is the number of moles of electron transferred, and F is the Faraday constant. Okay. So the correct answer will be option number 2. Now question number 62. Hi, here it is an assertion and reason type of question. So assertion is specific heat is an intensive property, and reason is heat capacity is an extensive property. Okay. So first we will read the assertion. Specific heat is an intensive property. Okay. So we will know that intensive property is independent of amount of substance present. Okay. So intensive property is independent of independent of amount of substance. Independent of amount of substance. And extensive property depends on the amount of substance. It depends on the amount of substance. Okay, so now intensive property is independent of amount of substance, yes, and specific heat is defined as the amount of heat required to raise the temperature of 1 gram or 1 mole of an atom by 1 degree Celsius or 1 Kelvin. Okay, so since specific heat does not depends on the quantity of substance, so that's why it is an intensive property. So our assertion is absolutely correct. And the reason is saying heat is an extensive property. Yes, extensive property depends on the amount of substance present. Yes, heat capacity defined as the amount of heat required to raise temperature of a given amount of substance. Okay, so here it is dependent on the amount of substance. Depends on amount of substance. So it is also, so it will be an extensive property. Okay, so we have the correct assertion, we have the correct reason, but assertion is not the correct explanation of reason. Okay, so the option number 2 will be correct because both assertion and reason are true, but the reason is not the correct explanation of the assertion. Okay, so the correct option is 2. Now question number 63. Plant and living beings are example of isolated system, adiabatic system, open system, or closed system. Okay, So we know that and living beings plant and living beings can exchange can exchange energy can exchange energy, as well as matter. So they are the example of open system. We know that if we can exchange energy and matter, so there will be an open system. Okay, so the correct option would be option number third. Now question number 64. The half life of a first order reaction is, okay, so we know that the half life of first order reaction will be 0.693 divided by k. Okay, now let's read the question. It is 0.693 divided by k. So now let's read the option. First is independent of the initial concentration of reactant. Okay, directly proportional to the initial concentration of reactant, inversely proportional to the initial concentration, directly proportional to the square of initial concentration. Okay, so we can clearly see in the formula that it is independent of concentration. Okay, so the option number 2 is incorrect, 3 is incorrect, and 4 is incorrect. Okay, and independent of initial concentration, yes, option number A is correct. Okay, so the correct option will be option number A. Now question number 65. Order of radioactive disintegration reaction is, okay, so we know that radioactive disintegration reaction are of first order because the rate of disintegration depends on the concentration terms of the radioactive material only. Okay, so we know if if reaction if reaction depends on if reaction depends on concentration, then it will be first order reaction. Okay, and in radioactive disintegration, it depends on the concentration, so it will be the first order reaction. So the correct option is option number B. Now question number 66. According to collision theory of chemical reaction, okay, so we have to answer according to the collision theory of chemical reaction. Okay, so the first option is a chemical reaction occur with high molecular collision. Okay, and second option is rate is directly proportional to the number of collision per second. Yes, this is absolutely correct. Reaction in gas phase are always zero order. It will not be always zero order. It can be first order, it can be second order, but not always zero order. Okay, reaction rate are of the order of molecular speed. No, they are not the order of molecular speed. Okay, so this is incorrect, and a chemical reaction occurred with every molecular collision. No, it is not necessary that with every molecular collision there will be a chemical reaction. Okay, so the correct option will be option number B. The increase in collision frequency brings an increase in effective collision. Thus, the rate of reaction increases. Okay. So, according to collision theory, the rate of reaction proportional to the frequency of effective collision. Okay. That's why the option number B will be correct, because rate is directly proportional to number of collision per second. So now let's come to question number 67. Here it is an assertion reason type question. Assertion is HClO4 is stronger acid than HClO3. Okay, and the reason is oxidation state of Cl in HClO4 is +7 and HClO3 is +5. Okay, so let's check. So first we have to draw its diagram. Okay, so the structure of HClO4. Here we have Cl, 1 oxygen, 2 oxygen, 3 oxygen, and 4 oxygen. Okay, and one H is there. Okay, so we can connect this by double bond, this by double bond, this by double bond, and one negative charge due to the H. Because we have removed H from here, so we get the negative charge on the oxygen atom. So it will be attached by single bond. Okay, so this is the structure for HClO4, and structure for HClO3 will be double bond here, double bond this side, uh, single bond here, and negative charge due to the presence of H. Okay, so now here we can see that here negative charge is managed by three electronegative oxygen atom. But here negative charge is managed by 4 and more number of oxygen atom than in HClO3. Okay, so HClO4 is stronger acid than HClO3 because the anion formed in HClO4 is more stabilized due to 4 oxygen, that is more electronegative atom. Okay, so the negative charge is more delocalized in HClO4. Okay. So the correct answer is B, because we have the assertion is right and the reason is also right, because the oxidation state of Cl in this compound is +7 and in this compound is +5. But the but reason is not the correct explanation of assertion. Okay, so the B is correct answer. Now question number 68. In question number 68, we have given the equivalent mass of, we have to calculate the equivalent mass of oxidizing agent in this reaction. Okay, so we have given the reaction SO2 plus H2S will give 3S plus 2H2O. So here, first of all, we have to find the oxidizing agent. Okay, so in this reaction, we can see that this here sulfur is in +4 oxidation state, and it is going in 0 state. Okay, so sulfur in SO2 is reducing, but it is oxidizing the other compound. Okay, so that's why SO2 is our oxidizing agent. Okay, and we know for calculating uh, equivalent mass, for calculating equivalent mass, it is equals to molecular mass divided by number of electrons gained or lost, number of electron gained or lost. Okay, so the molecular mass of SO2 is 32 plus 32, that is 64, and the number of electron that is changed, it is going from +4 to 0, means 4 electrons it has lost. Okay, so the correct answer will be 16, because 16 4 ja 64, so the correct answer will be 16. Okay, correct answer is C. Okay. Now question number 69. Here we are given with CR, CUX, and we have to use EAN rule, and we have to calculate the value of X here. Okay, so we know EAN is equals to number of valence electrons of CR plus number of electron donated by the ligand. Okay, and uh, it will be equals to EAN value. Okay, so we know that the that atomic number of chromium is 24. Okay, so chromium want to go to that oxidation state, or you can say it want to go the electronic configuration of krypton, because it is the next noble gas element near to the chromium, and its atomic number is 36. Okay, so we will take the En value equals to 36 here. Okay, so we know that value of En, uh, so we know that the value of En for chromium will be equals to 36, because the next noble gas element near to chromium is krypton, and its atomic number is 36. Okay, so En value is equals to 36, and the atomic number of chromium is 24, and the number of electron donated by the ligand. Okay, so each ligand will donate 2 electron. Okay, and we have to calculate how much ligand we have to use. Okay, so we can take the number of ligand as x. Okay, so here we will get 12 and 2x. Okay, so x is equals to 6, x is equals to 6, so the correct answer is option number 4. Okay, so we require 6 ligand, we require 6 CO ligands, 6 CO ligands. Okay, So now question number 70. Here question number 70 is saying which of the following is not a chiral compound. Okay, so we have to tell from the following which of the following is not a chiral compound. Okay, so what is chiral compound? A chiral compound is a molecule that cannot be superimposed on its mirror image. Okay, so this property is known as chirality. Okay, so from the option we can see the first option is M. Uh, the compound is Ma3B3 type. Okay, so we know that Me3B3 type, its geometry can't exhibit chirality because it has three identical NH3 group, or you can say three identical A group and three identical Cl group. Okay, so there is no possibility for creating non-superimposable mirror images. Okay, the correct answer is option number A because it is the type of Ma3B3. And if we check all other option, here the metal is not in that form that cannot exhibit chirality. So all these will exhibit chirality. All this will exhibit chirality. Okay, so we have to tell which of the following will not a chiral compound. Okay, so the option number A is not a chiral compound. Now come to question number 71. Okay, so what question number 71 is saying? In an octahedral complex central metal is F3 plus, Fe3 plus. In presence of strong field ligand, it shows paramagnetic character due to presence of. Okay. So first of all, we have given with Fe3 plus. So first we will calculate its electronic configuration. Its electronic configuration will be the electronic configuration for Fe is 4s2 3d6. Now for Fe3 plus, it will be 3d5. Now we will draw its orbital diagram. So we are given with octahedral complex. Octahedral complex. Okay. So now here the energy diagram will distribute in two parts. It is the T2G part, T2G part, and it is EG part, EG part. So we are given with the strong field ligands. Means electron will be filled. So we have to fill D5. Okay. So the first electron will go there, second electron will go there, third electron will go there. But it is strong field ligand present. So the next electron will go to T2G, not to the EG. Okay. So now the fifth electron will go here. Okay. So we got the one unpaired electrons. So the correct answer will be option number 4. It is asking how many unpaired electron will be there. So we have a one unpaired electron because due to the strong field ligand, the pairing will be done in T2G before the filling of electron in EG. Okay, so the correct answer is option number 4. Now question number 72. If S and KSP are respectively solubility and solubility product of a sparingly soluble binary electrolyte, then so we have to tell which of the following options are correct. Okay. So we are given with a binary solution. We are given with a binary electrolyte. Okay. So if we take binary electrolyte as B, so it will decompose in two compound because binary is written there. So let's take A plus aqueous and B minus aqueous. B minus aqueous. Okay, so the solubility will be S and S there. Okay, solubility of A plus ion will be S and B minus ion will be S because there is no coefficient, so no squaring will we have to done. Okay, so now we have to calculate the solubility product. We know that the solubility product Ksp is equals to concentration of A plus, and concentration of B minus. Okay, product of their concentration and the concentration of A plus is S solubility and B minus is S also. Okay, so Ksp is equals to S square. So S is equals to under root of Ksp. So the correct answer is option number C because S is equals to under root of Ksp is given there. Okay. Now comes to question number 73. Question number 73 is asking which of the following is more soluble in water. Okay. So if we have higher value of S, higher value of S means highly soluble or you can say more soluble, more soluble. Okay, so we have to calculate the value of S from um, all these options, and for the option which have the highest value of S, it will be more soluble in water. Okay, so first of all we will calculate for MNS. It will destroy in form of Mn2 plus, or you can say break in Mn2 plus plus S2 minus. Okay, so here the solubility will be S and S. So the solubility product Ksp is equals to S square. Similarly for zinc, it will be Zn2 plus plus S2 minus. Okay, so here also the solubility product will be S square. First of all, we are calculating the solubility product for uh, all the options. Okay, now for Bi to S3, it will be break in form of 2Bi 3 plus then 3 times of S2 minus. Okay, so the solubility product Ksp will be 2s whole square, because we have to write 2 from the stoichiometric coefficient, and we have to also square the stoichiometric coefficient. Okay, now into 3s and cube, we have to write the stoichiometric coefficient at that place and cube the stoichiometric coefficient as well. Okay, so it will give 110 s5. Okay, and now for last option, ag2 ag2s, it will break in form of 2ag plus 2ag plus then s2 minus. Okay, so here 2s square and s, so the ksp value will be equals to 4s cube. Okay, now we can easily calculate the value of s by in the first we are given with ksp is equals to 8 into 10 raised to power minus 37. Okay, so we can calculate by s square is equals to 8 into 10 raised to power of minus 37. Okay, in second option we can calculate s square is equals to 10 into 7 into 10 raised to power of 9 minus 16. In third option 108 s power 5 is equals to 10 raised to power of minus 70. Okay, similarly we have to calculate for all the option, and at last we have to check the in which option we are getting the highest value of s. Okay, so for which option we are getting the highest value, it will be our answer, because higher the value of s, higher will be its solubility in water. Okay, so when you check, the correct answer will be option number C, because it has the highest value of s. Okay, so we can calculate by 108 s to the power 5 is equals to 10 raised to power of minus 70. Okay. So now let's come to question number 74. Okay. Here we have to find what will be the pH of solution obtained by mixing 25 ml of 0.2 molar HCl with 25 ml of 0.2 molar BaOH whole twice. Okay. So here we have given with one base and one acid, and we have to find the pH of the resultant solution formed by mixing the base and the acid. Okay. So for this type of question, first we will find the moles of HCl. Okay, of moles of H plus ion. Then we will find the moles of OH minus, so that we can find the resultant solution is an acid or base. Okay. So here first of all, we are finding millimole of OH minus. Millimole because here the volume given in ml. That's why millimole. Okay. So BaOH whole twice. It will break in Ba2 positive plus 2 OH minus. Okay. Now millimole. Okay. And we know that molarity or concentration is equals to number of moles divided by volume of solution in liter. So here we are calculating millimole, so we can take the volume in ml also. Okay, so molarity given for OH minus will be 0.2. Now number of moles we have to calculate, so we can write moles, and volume given is 25 ml. But here we are getting 2 moles of OH minus, so we will multiply this by 2. Okay, so here moles will be 25 into 2 into 0.5. Okay, so this will give 25 into 0.2 into 2. Okay, oh, because here the concentration is 0.2. Okay, so it will give answer 10. Okay, now similarly we will calculate for H plus, that HCl will break into H plus, then Cl minus. Okay, now we will calculate its mole also. Okay, so molarity or concentration given here is 0.2, number of moles we don't know, and volume of solution is 25 ml. 25 ml. Okay, so moles will be 25 into 2, which is equals to 5. Okay, so millimoles of OH minus is 10, millimole of H plus is 5. Okay, so when we mix these two, then what will be the resultant solution? Okay, so 10 moles of OH minus will dominate over 5 moles of HCl. So 10 minus 5 is equals to 5 millimole. Okay, so we have 5 millimoles of OH minus now. Okay, so again we will use concentration formula, that is molarity is equals to number of moles divided by volume of solution in liter. Okay, so now we will calculate concentration or molarity, because number of moles is 5 and the volume of resultant solution will be 25 plus 25, because 25 ml of HCl and 25 ml of BaOH whole twice is mixed. Okay, so it will be 50. So it will comes concentration of resultant solution will be 0.1, 0.1 molar. Okay, so OH minus concentration will be 0.1. Okay, now we can calculate its pOH. If the concentration of OH minus is 0.1, then pOH will be 1. pOH will be 1, and we know that pH plus pOH, pH plus pOH is equals to 14. Okay, so when pOH is equals to 1, then pH will be 30. Okay, so the correct answer is option number C. Okay, so now let's come to question number 75. Here we have to find the incorrect order. Okay, so the first one is covalent character. Okay, so we know that we can calculate or we can predict on covalent character by using Fajan's law, by using Fajan's law or Fajan's rule. Okay, so what Fajan's rule said? So according to Fajan's rule, when we have the greater the size of cation, then it will be less polarizing power and it will have less covalent character. Okay, means when we have larger cation size, then it will be have less polarizing power and less covalent character. Okay, so the magnesium, calcium, strontium, barium. Okay, so it will lie in this manner in the periodic table: magnesium, calcium, strontium, barium. Okay, so we know that down the group size of element increases. Okay, so when the size of element increases, then their polarizing power or covalent character decreases. Okay, so magnesium will have the highest covalent character, followed by calcium, strontium, and barium. Okay, so first one is correct. It it has correct order. Okay, now second one is thermal stability. Okay, so thermal stability decreases as the bond length between lead and the halide decreases. Okay, so if there is decrease in bond length, then there will be increase in thermal stability. Okay, and we know that the bond length of fluorine is minimum. Then we have chlorine, then we have bromine, and then we have iodine. Okay, so fluorine and lead have the highest thermal stability, followed by PbCl and PbBr. Okay, so this order is also correct. Now melting point of Kf, KCl, Kbr, and Ki. Okay, so melting point decreases as the ionic size of halide increases. If there in if there is increase in the size of halide, then there will be decrease in melting point. Okay, so we know that fluorine will have the lowest size among all the halides. Then it will have the highest melting point, followed by chlorine, bromine, and iodine. So this order is also correct. Also correct. So our answer will be option number 4. So we can also check the boiling point. It is given that helium will have the highest among the noble gases, but it is wrong. Why? Because boiling point increases down the group as the atomic size and the van der Waals force increases. Okay, so this will be the correct order. So our answer is option number 4. Now comes to question number 76. Find the incorrect order of size. We have to find the incorrect order of size now. Okay, so in first option we are given with lithium, then chlorine, then bromine. Okay, so first we know generally down the group size increases. down the group size increases. And when we go from the left side of the periodic table to the right side of the periodic table, then size decreases. So this is the general way, but there are many exceptions as well. Okay, so in the first we are given with lithium, bromine, and chlorine. Okay, so first of all, we know that the size of bromine will be greater than chlorine, and we know that the lithium will have the larger size than bromine because it is lying on the more left side. It is lying on the left side, and these are present on the group 17, which on the right side of the periodic table. So size decreases when we go from the left side to the right side. So this order is correct. Now lithium and magnesium. Okay, so lithium and magnesium will have the larger size than lithium. Okay, now option number three. Here we are given with carbon, then oxygen, then nitrogen, then fluorine, and carbon will have the highest size among this. Okay, so when we go from the left side to the right side, then the size will decrease. Okay, so the nitrogen will come to the oxygen place. So this order is incorrect. Okay, so the correct order will be nitrogen will have the highest size, then followed by nitrogen, then oxygen, then fluorine. As the atomic size decreases across the from the left to right, then the given order is wrong. Okay, so the correct answer is option number 3. Now comes to question number 77. Here, chemical nature of nitrogen oxide compound obtained from a reaction of concentrated nitric acid and P4O10 in 4 is to 1. This ratio is a stoichiometric coefficient ratio. So we have to find the nature of nitrogen oxide that is formed in our product. Okay, so we are first of all nitric acid mean HNO3 plus P4O10 P4O10, and it is given that nitric acid will we will have to 4 moles of, because stoichiometric coefficient will be 4. Now when we will react this, then N2O5 and HPO3 whole 4 will form. Okay, so this will be our product, and we know that N2O5 is an acidic oxide. It is an acidic oxide of nitrogen. So our correct answer will be option number 1, that is acidic. Now comes to question number 78. Question number 78. Given below are the statement about diborane. Okay. So here first we have to calculate. Diborane is prepared by oxidation of NaBH4 and I2. Okay. So NaBH4 BH4 plus I2. It will gives B2H6 plus NaI plus H2 plus H2. And this is our diborane. This is our diborane. This is our diborane. So option number A is correct. Okay. Now each boron atom is sp2 hybridized. No, each boron is not sp2. It is sp3 hybridized also. sp3 hybridized. Okay. So diborane has one bridge, three center, two electron bond. No, it will have two. It will have it will have two bridged, three center, two electron bond. Okay. Now, diborane is a planar molecule. No, it is a non-planar molecule. Non-planar molecule. Non-planar molecule. Okay. So, only correct option is option number A. So, correct answer will be option number 2 here. Only option number A is correct because. Now comes to question number 79. Okay. So, here the oxide without nitrogen bond is. Okay, so in for this question we have to draw the diagram, or you can say we have to draw all the structure. Okay, for N2O, for N2O4, for N2O3 and N2O5, and we have to check whether there is nitrogen bond is present or not. Okay, so when we draw the diagram of N2O, there is nitrogen bonding. When we draw N2O4, there is nitrogen bonding. When we draw N2O3, there is no there is nitrogen bonding. Okay, now when we draw N2O5, there is NON. So there is no directly nitrogen nitrogen bonding. No directly nitrogen nitrogen bonding means our correct answer will be option number 4, because it has not directly attached nitrogen nitrogen bond. No direct and bond is present. Okay. So the correct answer is option number 4. Now question number 80. Here the relative reactivity of acyl compounds towards nucleophilic substitution reaction are in the order of. Okay. So for the acyl compound we have to find the order of nucleophilic substitution reaction. Okay. So we know the relative reactivity of acyl compounds towards nucleophilic substitution reaction are in the order of. Okay, so the most reactive will be acyl chloride. Most reactive will be acyl chloride. Then we will have anhydride. Then we have ester. Then we have amide. Okay, so the order will be Cl. You can say RCl. Then RCO minus. Then we have ester group. Then we have amide group. Amide means RNH2 is amide group. Okay, so the order of reactivity will be acyl chloride, then acid anhydride, then ester, then amide. Okay, so the correct answer will be option number 3. Now comes to question number 81. Okay, which of the following compound is most reactive towards electrophilic substitution reaction? Okay, so we know the compound will be most reactive towards electrophilic substitution, in which the benzene ring will be most activated. Most activated benzene ring. The most activated benzene ring will be the most reactive towards electrophilic substitution reaction. And plus M group increases the uh, reaction towards electrophilic substitution, means plus M increases the reactivity of the ring, and minus M decreases the rate of electrophilic substitution reaction. Okay, so in benzene there is no plus M, no minus M group. NH2 is minus M group. Cl is have minus I and small plus M effect, and CS3 has strong, you can say, plus M effect. Okay, so option 4 will be correct answer, because in benzene ring here plus M group is attached. It will increase the reactivity towards electrophilic substitution by activating the benzene ring. Okay, so the correct answer will be option number 4. Now question number 82. The compound which will react fastest with AgNO3 solution. Okay. So we are given with the four compounds and we have to tell which of the following will give the fastest reaction with AgNO3. Okay. So the compound that will form after the reaction with AgNO3, the compound that will be most stable will give the fastest reaction with AgNO3. Okay. So when the compound will react with AgNO3. So from here it will remove the Br and it will form AgBr. Okay. From all of the following the Br will be removed. Br will be removed. And when we remove Br, there will be a positive charge. There will be positive charge there. Okay. There will be positive charge in all the compounds. And now we have to comment on the stability of the four compound. The compound that will be most stable will give the fastest reaction with AgNO3. Okay. So the option number A here, this, and here positive charge. So it is in conjugation positive charge, then single bond, then double bond, single bond, double bond, single bond, and positive charge. So it is in complete conjugation, and here it has 4 pi electrons, 4 pi electrons, and we know the compound that have 4 pi electrons and are in conjugation and planar, then that compound is anti-aromatic compound, anti-aromatic compound. And the second option will be non aromatic compound. Okay, non aromatic compound. And now option number C, option number C, here positive charge, one double bond here, one double bond here, and one double bond here. So this compound is also in complete conjugation, and here are 6 pi electrons, 6 pi electrons. So 4n plus 2 pi electrons, 4n plus 2 pi electrons. So this compound is aromatic compound, and we know that aromatic compounds are most stable compound. So this compound number 3 will give the fastest reaction with AgNO3. Compound one is anti-aromatic, which is most unstable, then non-aromatic, then aromatic, then also non-aromatic. So correct answer option number third. Now question number 83. Statement 1, in presence of DMSO solvent, the rate of SN2 reaction increases. Okay, so the structure of DMSO will be CH3, S double bond O, CH3. This is the structure of DMSO. Okay, now in presence of DMSO, the rate of SN2 reaction increases. Yes, this statement is correct. In presence of DMSO solvent, SN2 reaction rate increases. Now, DMSO is a polar protic solvent. No, DMSO is a polar aprotic solvent. Aprotic solvent. So, statement 1 is correct, but statement 2 is incorrect. So, option number third will be correct answer. This is the structure of DMSO and it is a polar aprotic solvent. Okay. Now, question number 84. Question number 84. Here we are given with a compound and we have to tell the trivial name, or you can say the common name of this compound. Okay. So the common name of this compound, this is benzene ring, then carbon, and then this group. So we know that this group will be benzyl group. Benzyl group. And another famous compound is benzene ring, and then this is phenyl, this is phenyl, and this is benzyl. So our question is asking for this, and this, the name for the compound, the common name for this compound is benzyl. Okay, so the correct answer is option number 2. I have told for benzyl also, this is the structure of phenyl and this is the structure of phenyl. There is a difference of one carbon. There is a difference of one carbon. Benzyl group has one more carbon atom that is attached to the phenyl group. So the correct answer is option number 2. Now, question number 85. How many pi electrons are present in pentacene? Okay. So first of all, we have to draw the structure of pentacene. So this is the structure of pentacene. And now here we have to calculate the number of pi electrons. Number of pi electrons. Okay. So we know that each double bond have one. Each double bond will have one sigma bond, one sigma bond, one sigma bond, and one pi bond. One pi bond. One Every double bond will have one sigma bond and one pi bond, and each bond will have two electron. Each bond will have two electron. Okay. So first of all we will calculate the number of double bond. Then the number of electron will be 2 into the number of double bond. Just double of the number of double bonds. Okay, so there is one double bond, two double bond, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so there are 11 double bonds, means double bonds. Then it will have 11 pi bonds as well, because each double bond have one sigma bond and one pi bond. So 11 pi bonds, and 11 pi bonds will consist of 22 pi electrons. 22 pi electrons. So the correct answer will be option number 2, 22 electrons. Now question number 86. Here the melting point of copper, Ag and Au, means copper, silver and gold, are of the follows the order. Okay, so which will have the highest melting point, which will have the lowest. Okay, so melting point depends on the conditions such as atomic size, metallic bond strength, and electronic configuration. Okay, so Au, gold, gold have a larger size and it have a stable electronic configuration as well. Stable electronic configuration, and it has a strong metallic bonding, or you can say strong metallic bonding. Okay, so due to the reason strong metallic bonding and stable electronic configuration, gold will have the highest melting point, then followed by silver, and then copper. Okay, then copper. So correct answer will be option number Now question number 86. The melting point of copper, silver and gold follow the order. So we have to tell the order of melting point among copper, silver and gold. Okay. So melting point depends on the various factors. The main factors are atomic size, metallic bonding strength and stable electronic configuration. Okay. By by using these three factors, we can say that copper has the highest melting point, then followed by gold and followed by silver. Means the melting point highest for copper, Cu, then for Au, and then for Ag. And the main factor are atomic size, then metallic bonding, and third is electronic configuration, stable electronic configuration. Okay, so the correct answer is option number C here. This is option number B and this is option number C. So the correct answer will be option number C. Okay, correct answer is option number C. Now question number 87. The melting point of copper is higher than that of zinc because, means it is saying copper has higher melting point than zinc. Then what is the main reason? Okay, the first is the s, p as well as d electron are involved in metallic bonding. The atomic volume of copper is higher. The d electron of copper are involved in metallic bonding. The s as well as d electron of copper are involved in metallic bonding. Okay, so first of all, only d electrons of copper are involved in metallic bonding. Okay, so option number A and option number D are correct. The d electron of copper are involved in metallic bonding. This is the correct answer. Option number C is correct. Now question number 88. Question number 88. The first ionization energy of the electron of the first transition series, means from titanium to copper, increases as the atomic number increases, decreases as the atomic number increases, do not show any changes as the addition of electron take place in inner n-1 d orbital. Okay, then D option is increases from titanium to manganese, then decreases from manganese to copper. Okay, the first transition energy also, the first ionization energy generally increases across the periods due to the increase in nuclear charge. Okay, so generally we know when we go from the left side to the right side of the periodic table, ionization energy increases. Ionization energy increases due to the increase in nuclear charge. Okay, however, in the first transition series titanium to copper, this trend is not perfectly linear. Okay, but despite of some irregularities, the general trend is the ionization energy increases from titanium to copper due to the increase in nuclear charge. So the correct answer is option number A. Now question number 89. Question number 89. The salt of Cu in plus 1 oxidation state are unstable because, okay, so we know that copper in plus 1 oxidation state is unstable. Why it is unstable? Because it shows disproportionation reaction and it forms Cu and Cu2 plus. In aqueous form, it disproportionate into copper solid and Cu2 plus ion. Okay, and the reaction is given here. And this reaction is known as disproportionation reaction. So the correct answer is option number B. Cu plus disproportionate easily to Cu0 and Cu2 plus ion. Okay. Now question number 90. Question number 90. Okay. The magnetic moment of a divalent ion in aqueous solution of atomic number 25 is, okay. So atomic number 25 is of manganese and it is written divalent, means Mn2 plus oxidation state is there. Okay, so first of all we have to write the electronic configuration for Mn. Electronic configuration for Mn is 4s2 3d5. Then 2 electron will be removed from the outermost shell. So Mn2 plus will have electronic configuration of 3d5. Okay, 3d5. Now one electron is there. This is d orbital, 3d orbital. Now each will have single electron. Okay, so here are five unpaired electron. N is equals to 5 and n is the number of unpaired electron, and we have to calculate the magnetic moment, and we know that mu is equals to under root n into n plus 2, where n is the number of unpaired electron. Okay, so 5 into may 7. So under root 35 is our answer, and under root 35 is approximately equals to 5.9. Okay, so the correct answer will be option number A, 5.9 Bohr magnetron. Okay, now question number 91. Match the following. Here we are given with the order and the property, and we have to check which property will satisfy the order. Okay, so first of all, chlorine is greater than phosphorus, then greater than sulfur, then greater than silicon. Okay, so first of all, we know that electronegativity is the tendency of an atom to attract electron towards itself. And in the given order, chlorine is the highly electronegative, followed by phosphorus, then by sulfur, then by silicon. Okay. We know that when we go from the left side of the periodic table to the right side, generally the electronegativity increases, and while going down the group, electronegativity decreases. Okay, when we go from the left side to the right side, electronegativity increases. When we go from up to down, electronegativity decreases. Okay. So A has the correct answer of option number 1. Okay. Now boron is greater than thallium, is greater than indium, and is greater than aluminium. Okay. So ionization energy is the energy required to remove an electron from an atom in its gaseous state. Generally, ionization energy decreases down the group and increases along the period. Okay. So same for the ionization energy. When we grow from the left side to the right side of the periods, then the uh, our ionization energy will increases, and we go down the group, it will decreases. It will decreases. So B has the correct answer of option number 2. Now, electron affinity. Okay, electron affinity is the energy change that occur when an atom gains an electron. Chlorine has a higher Chlorine has a higher electron affinity than fluorine despite of being in the same group. We know that there is an exception, that chlorine has a greater electron affinity than fluorine. Okay, so this order is also correct, and the order of electron affinity generally it follows the trend. When we grow from the left side to the right side, it increases, and generally by going down the group, it decreases. Okay, but there is an exception in chlorine and fluorine, that chlorine has higher electron affinity than fluorine. Now option number D, chlorine, then phosphorus, then sodium, then cesium. Then non-metallic character decreases down the group and increases across the period. Okay. So for this trend, our correct answer will be option number 4. So the correct option will be option number first. Option number first. Now comes to question number 92. Question number 92. As we move across the second period, from carbon to fluorine, ionization enthalpy increases, but the trend from carbon to fluorine for ionization enthalpy is carbon, then oxygen, then nitrogen, then fluorine. This is because, okay, so there is a change in order. Generally, when we go from the left side to the right side, ionization enthalpy increases, and down the group it decreases. Okay, but there is an exception, that carbon, then oxygen, then nitrogen, and then fluorine. Nitrogen is supposed to be there, but it has a higher ionization energy than oxygen. This is due to the very stable electronic configuration of nitrogen, because we know that half filled and fully filled orbitals are more stable. Half filled and fully filled are more stable. So this is the correct reason. Okay. So the electronic configuration of nitrogen is more stable than the electronic configuration of oxygen. Okay. So correct answer is option number 2. Now comes to question number 93. Which of the following statement is incorrect? Okay. So first one is, greater the nuclear charge, greater is the electron affinity. Yes. When we have the larger nuclear charge, then the electron affinity will be more. Okay. So this is correct. Nitrogen has zero electron affinity. Yes, nitrogen has zero electron affinity because of its stable electronic configuration. It has stable electronic configuration, as we know. Half filled and fully filled orbital are more stable. Okay. Now, electron affinity decreases from fluorine to iodine in 17th group. Yes, the electron affinity generally decreases, but from fluorine to iodine, there is exception that for the highest electron affinity will be of chlorine, followed by fluorine, then bromine, then iodine. Okay, so this is our incorrect answer. So this will our correct option. And the fluorine has the highest electron affinity. Yes, this is also correct. Okay, so correct answer will be option number 3. Now question number 94. Ligand in a complex salt are. Okay, so it is asking for the definition of ligand. Okay, we know ligands can be ion, neutral molecule, or even cation, also linked by coordinate bonds to central metal or ion. Okay, so the correct definition will be option number 4, ion or molecule linked by coordinate bonds to a central metal or ion. Okay, it is just the definition of ligand. Now question number 95. Which of the following species is not expected to be ligand? Okay. So first off is NO. NO. We know that there is lone pair present at the nitrogen, so it can donate its lone pair. So it can work as ligand. Option A is incorrect. Option A is correct. Now let's first check for option number C. We have NH2, then CH2, then CH2, and then NH2. So there is lone pair at this nitrogen also, and lone pair at the another nitrogen as well. Okay. So there is two lone pair present. So it can donate it to two lone pair and can work as ligand. So this is also a correct answer. And now for CO. We know that at CO there is a double bond attached with oxygen and carbon has one lone pair left. Okay, so it can also donate its lone pair and can work as ligand. But in option number B, NH4 positive, we don't have any lone pair, so we can't donate any lone pair, so it can't work as ligand. So option number B is our correct answer. Now question number 96. Which of the following do not represent linkage isomer? Okay. So we know that linkage isomer can be formed when there is a CN at one compound and NC at another compound. Or we can show by we have HCN at one compound and we have NCS at another compound. So this type of uh, molecules can show linkage isomer. Okay. Now let's check option by option. CuNH3, then PtCl4 and PtNH3, CuCl. So there is not such things. Now in option number 2, we have PdPH3 and we have NCS group. And another compound we have HCN group. So it can easily show linkage isomer. Similarly, in option number C and option number D, we don't have such type of groups, so they will not show linkage isomer. So it is asking for do not represent. So only B is representing, means A, C and D will not represent. Okay, A, C and D means our correct answer will be option number C. Now question number 97. In question number 97, we have the correct option for the rate that correspond to the overall first order reaction. Okay. So here we are given that the order of reaction will be 1. Okay. So order of reaction can be calculated by just adding the power of concentration. Okay. So in option number 1, 0 plus 2 is equals to 0. So the order is not equals to 1 means it is not a first order reaction. Now for option number B, we have 1 at this power 1 and B has also power 1. So 1 plus 1 is equals to 2. So it will also not show first order reaction. It is also incorrect. Option number C will all be also incorrect. But option number D, minus 1 by 2 plus 3 by 2, it will be equals to 1. So it's the order of the reaction will be equals to 1, means this is the reaction that correspond to the first order reaction. So option 4 is the correct answer. Now question number 98. Which of the following factor will favor the reverse reaction in a chemical equilibrium. Okay. Increase in the concentration of one of the reactant. So it will promote the forward reaction, not the backward reaction. Removal of at least one of the product at regular interval. This is also not the correct statement. Increase in the concentration of one of more product. When we increase the concentration of product, then the reaction will be then the reaction will be backward reaction. It will promote backward reaction. Okay. So the correct answer will be option number 3. Now question number 99. uh, Enthalpy of combustion of carbon to CO2 is minus 393.5 kilojoule per mole. The amount of heat released upon the formation of 32.5 gram of CO2 from carbon and dioxygen gas would be. Okay. So first of all, here we are given with the enthalpy of combustion of carbon. Okay, so the enthalpy of combustion of carbon is minus 393.5. Okay, now heat released on formation of 44 gram of CO2. Okay, so first of all we are given that enthalpy of combustion of 1 mole of CO2 will be delta H is equals to minus 393.5. Okay, so from this we can say that 1 mole of CO2 will be forming, 1 mole of CO2 will be forming, 1 mole of CO2 is formed, okay. And 1 mole of CO2 contain 44 gram, 44 gram. And so here we have to released on formation of 44 gram of CO2 is minus 393.5 kilojoule per mole, okay. So we are given that for, for 44 gram of CO2, heat release will be minus 393.5, okay. And we have to calculate heat released for 35.2 gram of CO2, okay. So for this question, we can calculate that how much heat will be released for formation of 1 gram of CO2. Then we can multiply by 35.2. Uh, from this, we can calculate that how much heat will be released uh, for 35.2 gram of CO2 when it will be formed. Okay. So for 1 gram of CO2, it will be minus 393 point minus 393.5 minus 393.5 divided by 44. So this will be equals to 1 gram of it will be equals to heat released when 1 gram of CO2 will be formed, and we have to calculate for 35.2 gram. So we can simply multiply this by 35.2 gram. So this will be our heat released while forming 35.2 gram of CO2. So while calculating, the answer will be minus 314.8 kilojoule per mole. So correct answer will be option number 2. Option number 2. Now comes to last question. Uh, the standard enthalpy of formation of CH3OH liquid from the following data. Okay. So it is saying that we have to form CH3OH in the product, and we have to calculate its enthalpy of formation. Okay. So there are some reactant present at the this side, and there will be some byproduct also present at this side. But CH3OH liquid in liquid form must be formed, and we have to calculate its enthalpy of formation from these three equations: equation number 1, equation number 2, and equation number 3. Okay, so we want CH3OH at the product side, so we can just reverse this reaction. Okay, so first of all we are reversing equation number first. When we reverse, we will get CO2, then H2O, it will give CH3OH and oxygen gas. Okay, so here enthalpy of formation is minus 726, but it will be become positive because we have reversed the reaction. Okay, now for equation number 2 and equation number 3, our main focus is just that we want CH3OH at our product side. Okay, now the equation second will remain same. Okay, now multiplying equation 3 by 2 we will get. Okay, so we are multiplying equation number 3 by 2. When we multiply equation number through number 3 by 2, we will get 2 times of H2O. 1 mole of oxygen will gives 2 moles of H2O. Okay, now so it will gives on adding all these three equation what we will get. Okay, when we add all three equation we will get carbon graphite, hydrogen, then a half mole of oxygen, and we will get CH3OH at our reactant. Okay, so what we are doing, first of all we are reversing equation number first. So CO2 in gaseous form plus 2 mole of H2O, then CH3OH, then 3 by 2 moles of O2. And now equation number 2 is carbon, then oxygen, then CO2. Now equation number 3, our final equation number 3 will be 2 moles of H2 plus oxygen will gives out 2 mole of water. Okay, so when we add all three equation, this H2O will be cancelled out by this. Now we have 2 moles of oxygen at this side and 3 by 2 moles of oxygen at this side. So half mole of oxygen will be present at the reactant side. Okay, so final equation will be, just a second, final equation will be 1 by 2 moles of oxygen. Now we have carbon at this side, this CO2 will be cancelled out from this. So carbon plus 2 moles of hydrogen is present, and all these things are cancelled out, and CH3OH is present here. CH3OH. Okay, so we got the CH3OH at our product side. So now we just have to add or subtract the enthalpies. Okay, so enthalpy for the first reaction is plus 726. The enthalpy for the second reaction is minus 393, and enthalpy for the third reaction will be minus 572. Okay, minus 572. So 726 minus 393 minus 572. So it will gives minus 239 kilojoule per mole as our answer. Okay, so correct answer will be option number 1. Okay, so that's it for this session. Thank you so much.